talk about solving proportions today. And a proportion is two equal ratios. Now, a ratio is just a comparison of two numbers. So this right here is a ratio, and this is a ratio. This is a ratio, this is a ratio. But in order to have a proportion, we have to have two ratios that are equal. Now, just because I write that they're equal doesn't mean that they are. I mean, I could write on here that 5 equals 3, but that's not true, is it? But I can just look at that and tell it's not true. But I need to know how I can look at a ratio and tell if it's proportional or not. So sometimes you can reduce the fractions and tell if they're the same. But what we're going to do is a little trick. Now, we use this trick when we are trying to decide whether or determine which fractions were bigger. But we're going to do some multiplying. 21 times 5 is 105. And if I go this way, 7 times 15 is also 105. So when we were comparing fractions, we did this little trick, and then the one with the bigger number, then we knew which fraction was bigger. But I want to know if they're equal. So if my numbers come out to be the same, then they are equal, and then that means that they are a proportion. So if you're given two fractions that are equal and you're asked, is this a proportion? You just cross up and multiply, and if it's equal, then yes, it is a proportion. So let's try this one. 25 times 84, 2,100. Then 100 times 22 is 2,200. Now, those two numbers are not equal to each other, so this is no. This one is not a proportion. Now, I can also find missing values by using proportions. Now, this is a really important skill because we've been talking about solving equations in order to find x's, but now this looks a little different. But we can still do it. And we're going to use our cross multiplying again, just like we did to determine if it was a fraction. But when I multiply, I'll do one at a time. When I multiply this 48 times x, since I have a variable, I can't really multiply that. But I can just write it down. And remember, when we have a number and a variable multiplied together, we just write them next to each other. Okay, then I'm going to multiply 24 times 96, and that is 2,304. Now this is called cross multiplying. Cross multiplying. I don't know why my pen keeps messing up here. Cross multiplying. Because we multiply in kind of this cross form. All right, now I have a one-step equation that I can solve. So to get x by itself, I'm going to divide by 48, and if I do that to one side, I have to do it to the other. So 2,304 divided by 48 is 48. So x is 48. Okay, let's try this one over here. Same thing. We're going to multiply 27x and 81 times 9 is 729. I got a one-step equation, so I need to divide both sides by 27. And I get 27. X is 27. Now, we can use these proportions when we're given a word problem if we can make some comparison. So, let's see. Let's read this one here. If 35 pounds of turkey will feed 63 people, then how many pounds of turkey would be needed for only 9 people? So what am I comparing here? Well, it looks like I'm comparing turkey and people. Turkey and people. Turkey and people. important when you're setting up a proportion that you do this part right here, that you decide what you are comparing, because this is going to help us decide where to put all of our numbers. So turkey and people. So my first proportion, or my first ratio, sorry, is going to be this given information up here. 35 pounds of turkey, so turkey goes on top, feeds 63 people. Okay? And then I'm going to do this next one, I'm going to do a ratio of my other information. How many pounds of turkey for 9 people? Well, 9 people. People is on the bottom, so 9 goes here. And I don't know how many. That's okay, because we can actually put something in when we don't know. What do we use when we don't know a value? We use an X. So I put X in there. And now I have a proportion set up that I can solve. Okay, so let's do our cross multiplying, and we'll just solve this. 63 times X is 63X. 9 times 35 is 315. Divide by 63, divide by 63, and X equals 5. So it is a word problem, so I can't just leave my answer like this. What is this 5? Is it 5 turkey or 5 people? Well, if I go back up and look at my X, it's on the top. And remember, the top was turkey. So I need 5 pounds of turkey. That is my answer. You need to make sure that you label it all completely, the pounds and the turkey. All right, let's try this one. Is it true or false that if a plant grows 3 inches in 7 days, then at the same rate, the plant would grow 21 inches in 63 days? So I'm going to look for the two things I'm comparing. So it looks like I'm comparing inches to days. Inches to days. Okay, so I'm going to write that down. Inches to days. Okay, so now I'm ready to set up my proportion. This one is the first one, right here. 3, I'm going to write this 3 down here so we can kind of see it all together, okay? 3 inches in 7 days. So inches go on top, days go on the bottom. And then I have this one down here that is 21 inches in 63 days. Now, I don't have an X here, but it just asked if it was true or false. So what they want us to do is find out if this is a proportion. So we're going to use our cross multiplying and do 7 times 21, which is 147. And then we're going to do 63 times 3, which is 189. And that is not the same, is it? So this is false. That is not the same rate, or the same ratio. Okay? So that is how you use proportions to solve equations or word problems.